Greetings all and welcome back to the channel. Today we're getting back with the Technics M245X DBX equipped two-head machine. And you may remember in the last video we found that there are quite a few bad capacitors in this. Well, two that we know of for sure, and probably multiple others. Because back in the early 80s, Technics used their own brand of capacitors, rather Matsushita did, and those capacitors weren't very reliable over the long term. They had a real problem with that in the late 70s and early 80s, and it took them quite a while to become the reliable capacitor powerhouse that they are today. But yeah, this is one of the dangers you run into with early 80s and late 70s Matsushita gadgetry like this. So this is going to be my official experiment as to whether or not it's a good idea to replace polarized audio chain capacitors with non-polarized. And I've got the whole assortment here. I've got this whole thing full now. I've got my latest order in and I'm ready to go on this. So go we shall. And I wanted to use this machine because A, it needs the new capacitors anyway, and B, if I screw something up with this machine, it's not going to matter all that much. I don't want to do this experiment with one of my expensive 3-headers. Okay, now capacitors. I've got them all listed out here. And I'm just going to go one by one and check them all off as I do them. Probably starting with the power supply first. But I should mention real quick that not every audio chain capacitor is getting the non-polarized parts. There are some you can't get away with that with. And I've got them listed here. I believe this one here is on the DBX circuit. That has to be low leakage, according to the datasheet of that chip. And this one might also be the same. I'm not sure. I can't think offhand if that's a set of them or not, but I'm going to do both of those in the low leakage. I'm going with Nikon UKL for those parts, which are apparently end of life now and leaving the market. So I'm kind of glad I bought them when I did. But yeah, every last one of these up here is going to be the pretty green Nikon Muse parts. So basically the idea is to see whether or not the manufacturer chose polarized parts because of cost or if it's because of audio quality. And if I'm not satisfied with these, I'll go back in with regular polarized parts. But yeah, we're just doing an experiment to see how this works out today. So yeah, I'll just go through them one by one, check them all off as I do them. I have to take the transport back out to do one of them because there's one on the little circuit board in there, but hopefully that's the only one. I think I thought about getting back in there with better quality belts, but honestly this transport is performing well enough as is that I don't have to worry about that, I don't think. So yeah, there's really not a lot to see unless you guys want to watch me change a bunch of capacitors all day, and it's probably going to take all day, probably more than one day too, but yeah, I got all the parts I need here. And you might be wondering how much this is costing me. Well, the deck itself was 90 bucks shipped. I don't remember exactly where the seller was located, but it cost me 90 bucks to get it here. And the capacitors were 80 bucks. So yeah, that's my investment on this thing. $170 for a 2-head machine. This is why I don't like to budget more than 100 bucks for 2-headers or 200 bucks for 3-headers. It gets real expensive real fast, especially when you have to change all the capacitors like this. Anyhow, let me get the cover off and I'll show you the worst of the capacitors. So the cover is off now and you are about to see the worst of the worst. You see those lilac capacitors there? You see the green corrosion around this one up here? Yeah, that one's already leaked out and gone bye-bye, as has its little buddy over on the other side here. These lilac capacitors are the worst of the worst when it comes to Matsushita capacitors. If you see them, change them. They're all dead. These other ones, they're probably not all dead yet, but they'll be drifting off capacity, and yeah, I'm going to test them one by one as I pull them and change them, but I don't know exactly how many bad ones I'm going to find in here. So, could be an awful lot of time being wasted for nothing, or relatively nothing, but yeah, I'll test them all as I get them out of there, and except for the power supply capacitors, I'm just going to change them right away. It's usually a good idea to do that anyway in something this old. But yeah, I got a lot of work ahead of me on this one, so I guess I better get started. So I'm midway through the recap. I got the audio chain capacitors done, but before I continued, I wanted to show you just what kind of damage really bad electrolyte can do to a circuit board. Check this out right here. This is under one of those lilac capacitors. There's supposed to be a trace going from here, through there, all the way over there. It looks extremely damaged to me. So I'm going to have to check and see if there's anything left of that connection, and if there's not, install jumper wires. But yeah, you see what I'm dealing with on that DCC machine. Picture this only about maybe a tenth the size, and in the middle of circuit board layers. That's why those things are so hard to fix. That's why I don't suggest you buy one of those first generation DCC machines. But anyway, the machine's working fine so far with the limited amount of recapping I've done thus far. However, the meter board, one channel is in full deflection all the time, and I can't quite figure out why. I don't think it's something I've done. Rather, I think it's something to do with the connectors on that board, but I got to get in there anyway and change a bunch of caps on there, so I guess I'll continue. So I think I'm pretty well done with this unit. I've got the whole thing recapped. Well, I guess not the whole thing. There's a couple of that didn't get changed because I somehow missed them in the schematics, but most of them have been changed. Now before we get into the unit itself, I'll show you the bad capacitors. Here they are, right here. Of course, we've got the two Lilac Wonders, which are so corroded they've got legs falling off of them now. I did measure one when it was still able to be measured, and ESR was really high, but it was right on value for capacitance. So yeah, it's just these leak like crazy. I don't know if you can see it, but that one's been puking, and that one's been puking. So yeah, you see those lilac capacitors, you got to get rid of them instantly. Now, what was the issue with the popping noise I had in the last video? Well, that's this guy right here. After all that talk about me ranting about old Panasonic capacitors going bad, it happened to be an Elna that was the cause of the problem. And I'll show you where this one was. It was right here. Or no, wait. That's the one. That's where it was. It's connected directly to pin 8 of this IC right here. And this is directly in the audio signal path. It's one of the op-amp packages for the signal output. So yeah, that was the problem. Now, how did this measure, you may wonder? Well, I checked it a couple of times just to be sure. And it's right on capacitance, just about. I think it measured 53 microfarads, and it's a 47. However, oh yeah, and the ESR was good too. However, this was leaky, and I mean extremely leaky. I'll show you what happens when I try to test it here. Throw it on my little tester here. This thing has a problem reading this. Look how long it's taking to actually measure this thing. Yeah, it measures as a capacitor and diode, I think, in series. That's how bad it is. And there's no V-loss display here, which tells me it is so leaky that this thing is timing out before it can even measure the thing. So, yeah, that was the problem. That was the whole problem. I did a full recap job for 3 bad capacitors. But you can see all those pretty little green capacitors in there now. But I just wanted to stress to you that these bipolar green capacitors are only installed where there is no DC blocking present, or DC blocking required. These are only in where it's safe to go in with bipolars. You don't want to use bipolars where you need to block DC voltage, like around this DBX chip here. There are 4 UKLs installed in that area over there. Let's see, this one here and this one. These are the critical audio chain capacitors that absolutely have to be DC blocking, and they have to be low leakage. So those are the UKLs right there, or UCLs as I might want to call them in the future. But these 2 here are also UCLs because for some reason Panasonic wants you to use 5% tolerance capacitors here, and I couldn't find anything remotely like that. Best I could do was 10% with the UCLs. And these 2 are measuring about 6% off, so that's close enough to the 5% tolerance that I'm hoping it'll work. Now you're going to see a couple of fancy WEMA polypropylene capacitors here. There's one here, and there's one up here. These are in the DBX circuit as well. They're so low value you can't get electrolytics for those, but they're nonpolar and they're WEMA film capacitors now. And yeah, I found the issue with the meter board. It was one of these wires was shorting out on a neighbor, so that should be working now. But yeah, we got to test and see if it powers up now. And oh yeah, I've got a green capacitor over there. That's just because I didn't have a bipolar that was non-audio. That's usually what happens when you see something like that for me. But we are just going to plug it in now and see if it still plays tapes and if any magic smoke comes out, because some of these capacitors were really hard to install. So let's see what happens here. Power's on, meter looks good. I actually had some issues with this part of the meter as well when that wire was shorting out, but that should be fixed now. See if we get any audio out of her. I haven't got the home theater hooked up yet, but we can do that in a second or 5. And it is playing. Counter's working right. So I'm going to shut that off real quick, and I'm going to hook up the home theater. Ah, I love me some vaporwave cano. And of course DBX still sounds rotten because I'm playing back a tape not encoded in DBX with DBX, but we'll test out the DBX by and by. It sounds amazing so far. But if I'm being totally honest with you, I'm not really hearing much difference from the before result. I'm going to have to listen to this more extensively to make sure the the bipolar mod was actually worth doing. But yeah, it's performing well now. Not that it wasn't before. Yeah, I'm going to have to get this up either on the DCMs or the chambers in order to really determine whether or not the audio quality is improved. And it's very likely, I should mention, that I have to realign various parts of this now. And, oh, that reminds me, I should point out some other locations where I went in with the Autels. I'll unplug first, just in case. But, oh yeah, there's other things. I found some issues with the actual factory installed parts. Down here is the recording amplifier. You can see the two green Muse caps right there. But these are Autels. And Technics didn't have the parts installed here that were on the schematics. They were 1 microfarad at 50 volts. And on the schematics, they're 0.1 microfarad at 50 volts. So I made an executive decision to go by the schematic rather than what was in there. So very likely that the recording amplifier needs realignment now. But I can do that. I'm not sure if I'll do it on camera, but yeah, that's not the only place I found an issue like that. This one up here. This was supposed to be 33 microfarads. It was 100 microfarads. But in this case, I decided to keep the 100 and just leave that one be. But those were the only 3 parts that were basically not correct from factory. Or they were possibly correct and later modified without updating the schematics. But yeah. Considering I did all this work and spent all this money to replace 3 bad capacitors, I'm not sure that was worth doing at all. However, it's likely that I would have missed the actual problem capacitor if I hadn't done the recap, so I don't know. Is it possible that the blue Panasonic SUs, the dark blue ones that were in here before, are going to fail? Yes, possibly. I found some that were kind of getting leaky, but not quite. There were a couple that were sort of drifting towards high ESR, but pretty much all of them were still on target as for spec-wise. So I'm going to say by 1983 they had the issue licked with those parts. So earlier than 1983, I don't know. But yeah. Those lilac parts clearly were the worst ones. They were so badly leaking that the board was damaged here. In fact, on one side here, I had to completely solder in a jumper wire because there was nothing left to solder the negative or the positive lead of the capacitor to anymore. Or actually, no, I think it was this one, and it was the negative. Something like that. There was basically nothing left of the land to solder to, so it had been completely corroded away. And I had to come over to the actual chip itself and solder to that instead with the capacitor. But I got there, and everything should be working now. So I'm going to do a couple test recordings and see if this thing actually needs realignment first. And if it does, maybe we'll do that on camera. Maybe not. I don't know. This unit is very much like the RSB 755 for alignment. In fact, the procedure is nearly identical except for one issue. On this model, you can't do the shortcut. There is no off-tape monitoring because it's a 2-head. On this one, you have to record, playback, analyze the signal, see if it's in spec. If it's not, you gotta tweak, you gotta adjust, go back, record, playback, measure, wash, rinse, repeat, that kind of thing. Very tedious on a 2-header. But I'm just glad I didn't have to do that on the 755 because that one sounds amazing. But in the future, I will only do the signal chain capacitors with these parts. I'm not going to do a blanket recap on everything because clearly it's not needed on this one. And oh yeah, I'm very quickly coming to prefer these Panasonic FRs in the power supply. I think I'm going to keep using those. All three of these main filter caps are FRs. I tried a test recording on this machine. I used Tears for Fears' famous last words, like I often do in the case of wanting to see exactly how these things sound, and there was no high end in the audio. Now, I already know that the azimuth on this thing is fine. For one thing, I've checked it. For another thing, the playback high frequency response is fantastic on this unit. But, yeah, it lost all the high end from the audio, or from the recording amp. So what I've done is, I kind of suspect that UES parts are the wrong way to go. So I have replaced those with fine gold series capacitors. They're 100 volts because I couldn't find the 50 volt stuff anymore, anywhere, but they should work fine. And these other two capacitors here are UKL low leakage. So yeah, hopefully that fixes the record amplifier. If not, we're going to have to go in and we're going to have to probably realign the record amp frequency response, because I know it's out. And also the record level is out. Not to the same degree that the Sony TCK45 is, but it is out. So I don't know how much of this realignment I'm going to be wanting to do on camera, but yeah, I think I'll probably try to do the record amp EQ realignment on camera. But when it comes to the record levels, I'll probably do that one off camera, because it involves me having to check and double check levels like 300 times before I get them right, and I don't really want to trouble you with that. Also, there were further issues with the transport. Not major issues, mind you, just small issues. Basically what I found was it would rewind and fast forward properly, but when you tried to do music search and reverse, it would fail. Basically the fast wind idler couldn't turn the supply reel backwards. So what I did to fix that was I pulled the transport back out. I pulled the fast wind idler assembly off. I cleaned up the idler tire on it. It was not bad. It needed to be cleaned though. And then I put some moly coat on the pivot point up near the top here. You can't see it when it's assembled, but yeah, that's what I did. And as of right now, it's fast forwarding and rewinding, and it's doing music search in both directions flawlessly. And the other thing I noticed was at certain times this thing would flake out when going into stop mode. It would stop and then play, and then stop and play, and stop and play. And the cause of that was the micro switches on this side for the control of the machine. You'll remember that I cleaned them up using Deoxit D100, and apparently the D100 wasn't enough. I had to go in and burnish the contacts on those switches. So that's working fine now. But yeah, I got to do another test record, and then we'll see how this thing sounds, and maybe I'll be back with an alignment portion, and maybe I'll be back with a record and playback test. We'll see. Well, mixed news on this. I'm happy to report that the switch from the UES parts back to polarized parts in the fine golds in the recording amp EQ has restored the high end to this machine. Somewhat. What it has not done is it has not tamed the low end. This gal's got a badonkadonk on her right now. We're getting a lot of energy, around 50, 60 hertz or so, off this machine. And if you pull in DBX, it sounds, well, even more pronounced, but I'm actually not sure whether or not this is intended to sound this way from the factory. With that being said, I want to check the alignment on the record amplifier just to be safe. Now, I want to talk about these directions here for a moment. Well, maybe it's better if I hold you like this. See, the way Technics has you doing this is a little convoluted here. Let's see, the conditions: record playback mode, normal tape mode, CRO2 tape mode, input level control maxed out, output maxed out. Let's see, balance center, And they want you to do all this convoluted garbage here in order to measure this. You've got an AF oscillator here, attenuator here, 2 VTVM oscilloscope combos. I can only do one set of measurement at a time on the scope, but hopefully I've got all the tools I need in just the one scope here. I don't know. Anyhow, what Technics wants you to do is they want you to put a 1 kilohertz signal in through the line in, attenuate it so it's minus 20 decibels, which should be about 0.1 volts or so. And then they want you to run 1 kilohertz, 50 hertz, 100 hertz, 200 hertz, 500, 4 kilohertz, 8 kilohertz, 10 kilohertz, and 12.5 in, and record those signals, then play them back and see if they're within the specified values. I don't see why I need to go through all that kind of garbage in order to tell me what I already know, that that there's too much low end coming out of this machine. See, from about 100 hertz all the way up to here, it's flat. It's just I'm getting a little bit too much down below 100 hertz. So why do I need to do a 9-band EQ here just to tell me what I already know about this machine? Why can't I just go to adjustment B here and twiddle on VR 301 and 302 until I get the curve correct? Granted, you have to go back after doing this and do all this stuff all over again, or so they say. I'm not going to do all that stuff. I'm going to do 3 bands. I'm going to do maybe 50 hertz, 1 kilohertz, and 10 kilohertz, and that should tell me all I need to know. But over on this page here, we've got at number 10 here, confirm that bias currents are approximately as follows when the unit is set at different tape modes. Why don't I just skip straight to this here? Why do I have to go through all these adjustments in order for me to even check this? Why don't I just do it now and see if it's within the specified value here? So that's what I'm going to try to do now. With that said, I'm probably getting a little bit too shortcutty with this thing. They've probably got you doing all that stuff for a reason, but yeah, I want to check the bias currents here. So that's what I've got this set up to do now, theoretically. And as far as the test points go, they've got those clearly marked, except they don't really have the negative or the ground marked. And what they want you to do is get the ground from one of these resistors down here. I don't want to do that either because that's impossible to connect to. So what I'm doing is I'm getting the ground from the connector over here. So I hope that that is sufficient for this. If it's not, well, who cares? It's my personal machine. But yeah, I got to get used to doing adjustments like this. So I'm going to load a normal tape first. Preferably one without the little stickers on the back of it so it wouldn't go in. But yeah, I'm going to try this with normal tape and metal tape only. I'm going to skip chrome. I don't see the need to waste my time with that either. But yeah, should be set up to go here. I'm going to go into record pause mode here. I'm going to go over to my signal generator. And let's see, they want 1 kilohertz, I do believe. So we'll just set this as 1 kilohertz. And we will try that. Okay, now what we got going on in the meters here? That doesn't look like minus 20 decibels to me, quite frankly. But you realize, of course, that... oh, I gotta switch out the noise reduction. Yeah, I don't know. This seems like it's really peaked out. But I can't do the adjustments yet on the record and play level because they have you doing that after this. So, I don't know what to do here. I could try 0.775 volts. That did bring her down. I'm just going to keep going down on this till I get the right value in the level meters. And this looks like it's about correct here. So I'm going to try this. I don't know if it's going to work. We don't have to make any adjustments at all, really. So I'm not going to worry about that too much. Okay, now I'm going to record this test tone here. I think they want you to do that for step 10 here. Okay, I think I might have gotten this figured out now. I'm not exactly sure. Like I said, extremely new to these type of measurements, so yeah, forgive me if I mess things up or don't get things quite right, but the measurement or the test points I've got connected right now are just for the bias current. They're not for anything else. So if you want to actually measure the frequency response, it has to be done from the line out, not from where I've got the scope connected right now. So yeah, right now we're just measuring bias current, I think. And I've got a metal tape in right now, and these are the values we're getting. On the left channel, which is the up top here, that's the one we're currently measuring. We're getting around 28 volts peak to peak. It's kind of bouncing around a bit, so 26 volt, we're going blah, 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 blah. 26 millivolts, I think we're getting, which corresponds to, well, it's actually kind of low. You're supposed to divide volts by 10 in order to get the bias current, according to this service manual here. So, let's see here. Do I turn that up or do I leave it alone? See, the problem is channel 2 is extremely out of control here. Let's see if I can switch the measurement over. I think it's out of control. I'm not sure. Let me set the scope up so it's reading the same value as the other channel. See, that's what I get on channel 2 here. That one's actually quite high. So the question is, do I bring up channel or the left channel to match the right channel, or do I drop the right channel to match the left channel, or do I go somewhere in between? And I think I might have to go somewhere in between. So I'm going to twiddle on this, and we're going to see what happens. Like I said, it's my deck. I don't care. Okay, let's see. Right channel is which VR pot? VR302. See if I can find it here. See if I can get my tool in there without knocking loose my probe, because it's in a bad spot there. Okay, I'm going to tweak the right channel down. Well, this is very odd. I don't seem to have enough adjustability on this to do much here. Let me check my values here. It should be around 380 microamps. I'm just not sure what the heck is going on with this unit right now. Let me go back to left channel. Okay, that's come up now, but then why hasn't the amplitude increased in the display here? Well, folks, I give up. I can't get this thing to cooperate. So what I'm going to do is I'm just going to do the multiple test tones. Well, first I'll reset the pots back to where they were, and then I'll do the multiple test tones. I'll record them over and over and over as many times as I have to, and then I'll get it dialed in that way. And I'm not going to worry about these bias currents at all, because apparently those pots don't really change anything with that. measurement. So yeah, that's what I'm gonna do. Probably do this off camera because I feel like I've wasted enough time. So let me get to that and I'll try to get it dialed in and we'll see what happens. Well, folks, I'm all done and I was not able to tame the frequency response on this guy. It's just got too much going on around 40 hertz or so, and I can't adjust it to compensate. So here's what I did. I ended up doing 5 passes, 4 with metal tape and 1 with normal tape. I decided to go straight to the metal stuff because why wouldn't you? I don't know why Technics has you doing it normal tape first and then going up to metal, but whatever. I figured if I could get metal under control, then, well, that's fine. Pass 1 is where I had it adjusted the last time I fiddled with those controls. And let's see here. I got 1.14 volts at 40 hertz, 840 millivolts at 500 hertz, 680, 580, and 580. So it clearly needed tweaking there, so I went to pass number 2. And if you're wondering what this is, it just means me keeping track of the numbers on the counter there. Every 10 on the counter means I go to a different frequency. So pass 2, 1.06, 780, 656, 672, and 752. You can see the treble has come way up there. And possibly that's where I should have left it, but I didn't leave it there. Pass 3 is the one I ended up going with. 1.08 volts, 776, 640, 672, and 744. I thought this was the most balanced I could get it. And coincidentally, that's right about where I started from at the beginning of this video. That's where the factory defaults were. Anyhow, I went to a pass 4 where those controls were almost bottomed out, and I got 1.04, so it was starting to get the low under control a little bit. Then 768, 640, 704, and then 768. And then I did another and then I went further than 10 kilohertz on that one. I went to 15 kilohertz. That's the number in brackets there. So I thought it was emphasizing the extreme highs too much on pass 4, so I went back to pass 3 and set it back there. And then I did this run with the normal tape here, and I got these numbers: 1.03, 760, 640, 736, 664. So yeah, I'm going to leave it right there, number 3, and we're just going to let her twerk with her badonkadonk here, I guess. Because I can't get it under control any better than that. It's clear that this needs a little more modification to the record amp equalizer than capacitors alone can provide. Probably needs a whole new record amp, dual op amp chip in it. But I'm not really that interested in playing around with it right now, so I'm probably just going to leave this as is and enjoy it the way it is. Now, I should mention, at 5 kilohertz and 10 kilohertz, I've got a left and right channel imbalance, slightly. The right channel is just a hair lower than the left channel, and there's no way to compensate for that via the pots I adjusted, and you can't compensate for that in the playback levels either, because it's something going on with the head, I think. I checked the azimuth beforehand. It was fine. I checked the playback levels beforehand, and that was fine. So, yeah. This right here is probably about as good as the deck's going to get, because I don't want to invest any time and resources into trying to modify a 2-header any further. But, yeah. I'm going to say that if you're looking to change out some capacitors on this guy, let me shut things down here so I can swivel this thing around. So what I'm going to say, when it comes to all these new capacitors in here, go ahead and do the UES parts on the playback amplifier. Everything in the signal path, go ahead and do UES, except for around the DBX chip, in which case these two here need to be low leakage, polarized. And so do these two, because these are where those lilac pieces of crap were. But, and oh yeah, I got WEMA over here. That's because I couldn't find non-polarized caps and the right values for those locations. So I went film instead. Instead of UES parts. So yeah, the playback out of this thing sounds amazing. Record, not so much, but I kind of had the feeling it was going to go that way. So I'm going to play you some of the demo tape it made earlier, or some of the demo recordings this machine made earlier. And you can see how it sounds for yourself. But as far as this deck competing with the Nakamichi BX150 and 480, I don't think it can get there without more extensive modifications than I've gotten done today. It just needs a lot more done to this record amp equalizer down here in order to get the flatter frequency response I would hope to get from it in order to do that, but it sounds good enough. For playback, it sounds equal with the Nakamichi units. I'm going to just say that right now. It's just recording is kind of where it falls on its face a little bit. But it's not bad. It's fine. You'll hear it and see. One more quick little segment before we get to the record and play test on this guy. I decided it was kind of irresponsible of me to just leave it the way it was and just kind of roll into the record and play test without recalibrating the record levels inside the machine first. So I've done that now. What I also did was I went into the DBX and I recalibrated the attack delay time on that particular circuit. It wasn't far off. Actually, it wasn't off at all. I think they want you to align it to 15 millivolts, and it was 15.5, which is right at the edge of the tolerance they allow for that. But I got it dialed in perfectly now, so what you are about to hear is a recording on, as usual, a Sony Metal SR using DBX, which, by the way, I don't think is our friend on this particular machine, but you're going to hear it anyway. Source material is, of course, coming off the Steinberg UR22. And yeah, it's about the best I can get this machine, so this is where it's going to stay. So I also picked a new track for the record and play test, one that's a little bit more appropriate for how this deck sounds, but yeah. Unfortunately, this is not the Nakamichi contender I was hoping it would be, but it's still pretty good. I don't think I would ever use DBX on this thing, but that's what I'm using it for now. Oh, interesting. Look at this. I didn't notice that. When you pull in DBX, it lets you go all the way up there. Very interesting. And there's Dolby B, Dolby C. But yeah, DBX goes right up to the top. Anyway, that's neither here nor there. Let's get to the record and play test, see how it sounds.